Good afternoon. Welcome to our webinar about the final presentation on the SGX3 summer internship at TACC. My name is Maytal Dahan. I am one of the co-PIs of SGX3. I lead the Gateway Central, I support technical consulting, and I help run the summer internship program. I'm also the director of advanced computing interfaces at TACC. And I have a 22 plus year history of gateway development, from creating gateway frameworks all the way to launching multiple gateways to production. A little bit about the internship program. So SGX3's internship is meant to provide a really immersive real-world experience that help prepare our students to contribute immediately to projects critical for research advancement, growth, and innovation. The interns get hands-on experience in software development for science gateways, both back-end infrastructure and front-end development. There's a significant growth opportunities here where interns learn to develop skills that place them into high-demand technology roles. And it's also a partnership with research and science gateway projects where interns get to experience what it's like being a cyber infrastructure engineer and understand the landscape and different domains of science. So we're really excited to have you here today to learn from our interns. We're going to be having 3 different presentations. So we're just going to hop right in. We're going to start with Sameera and Vani.
Yeah, hello everyone. My name is Vani Walvekar and I'm here with Sameera Sineen. We are the SGX3 intern for 2025 cohort, and we were working with web and mobile applications team, and we are really excited to present our work. Next slide, please, Maithil.
Yeah, hello everyone. This is Sameera. I am a recent computer science graduate from St. Louis University. And here at TACC, I have been working with web and mobile applications team on redesigning design safe dashboard using React, Python, and Tappis API. And I have hands-on experience on IT support, AWS, Docker, and I've even worked on many machine learning projects. And I'm really passionate about full stack development and cloud automation. Next slide, please.
Yeah, hi, this is Vani here again, and I am currently doing my master's in computer science in St. Louis University, and I have been working with IBM as a software engineer for almost 3 years, where I worked on automating the BAU tasks using Python and CL for mainframe computer systems. And also here, as part of the SGX3 internship, we worked on redesigning the entire dashboard using React, which exists in Angular now. Next slide, Maithil. Yeah. So before proceeding further, I'd like to thank everyone in our team for their invaluable guidance and support. I would like to thank Maithil for her wonderful ongoing support, and also the onboarding support. And also, I would like to thank Tracy. She's our manager. She worked. She actually supported us all along the way, starting from onboarding and at all part of our journey. I would like to thank all the mentors, Jake, Frank, Garrett, Saul, and Cheyenne. Jake was our primary mentor, and he supported us starting from making us understand the coding environment, and also he made us understand what are the best practices for the coding. Next slide, maybe. Yeah. So before moving further, I would like um, everyone to know what Design Safe is. So Design Safe is a web-based tool which actually uh, is a comprehensive platform for natural hazard research, which provides many tools such as data report for managing the data sets, which has a workspace for us to work with different tools such as Jupyter Notebook, MATLAB. So researchers can also run simulations on that tool. So for this web-based tool, what we had the objectives were to redesign the entire dashboard using React, which exists in Angular now. And also, once we designed the dashboard, we had to create a user guide on how to use that dashboard. Also, we had to plan if we have any ML features to implement on that dashboard for the better user experience. Uh, Next slide, Matt. As part of this internship, we worked on several components. There were four components which I worked on. The first one was recent projects. In this project, the front end code was retrieving all the project details from the backend API and normalize the data and displays to the user the most three recent projects he has accessed. Next component is the tickets, where the user was able to see all his open tickets and the resolved tickets. It was done again using a backend data retrieval from the backend API and normalizing the data and presenting it to the user for better user experience. The third component, which I worked on, was the recently accessed tools, which stores all the tools which the user recently accessed in a local storage. And that was actually browser-based storage. So we can also implement it using a database for the permanent storage. What it does is it will display all the recently accessed tools to the user. The fourth component which we worked on was the favorite applications, where we had created a model and a view in the backend. So there was one model which stores the user and the tool ID which the user want as a favorite application. And we had two views. One is to list the applications in the front end and also to add the favorites. We also had one more view to remove the application from the favorites. Altogether, we in the front end, we had a list of the applications which the user wants as their favorites. So it was enhancing the user experience and navigation. Next slide, Mike. As part of the ML implementation, we had a couple of ideas. So among those, one which I would like to mention is the storage analyzer. So as we can see, we deal with a lot of data in our day-to-day basis. Sometimes we will be having the data which we no longer need as well. So to manage with those kind of data, what we can do is we can train a model and it will suggest us which files can be cleaned up for the better storage. For that, we have again a backend where it will scan the user directory and it will extract the metadata of all the files, and it will scan the files if they are duplicate using the SHA algorithm. What it does is it will generate a hash ID for every file, and if the ID is same, then it will suggest the user for cleanup. So as soon as we click on the analyze storage button, it will pop up with a React model showing all the files which can be cleaned up or which can be archived if they are large enough and if the user is no longer accessing them. We can also integrate a isolation forest model where it will, based on the user's pattern, it will suggest whether that file can be archived. If there are small variations in the duplicate files, there'll be only a little variation in the hash IDs. So based on that, it will suggest the user for cleanup. So overall, it's a storage management idea which we can implement in the data report page of the Design Safe portal. So with this, I'd like to thank everyone for supporting us and guiding us throughout this journey. And I would like to ask Sameera to continue from here.
Yeah. Sorry. Hello everyone. Coming back to the components I have worked on. I would like to start with the allocations on the dashboard. Now dashboard will display the particular allocations of a user, which will clearly state what allocations they have been awarded, what are remaining, and what is the expiration date. This will give the user a better way of managing their resources, or a better way of managing their job submissions according to the allocations. To achieve this, I have been using TACC API, which will first authenticate the user using the credentials and then pull the project allocations that they have been awarded. This was already existing in the code base, but it was not returning the required fields. So I have just modified them a bit to get the required fields such as awarded, remaining, and expiration date. And then using a JSON mapping, I have mapped the system resource codes to a readable names. And then we have rendered this onto the front end using a React card component. And coming to the next feature, system status. This has been also achieved using TAPIS API, where this will be returning all the system data hitting the API's proxy status endpoint. After getting the data from that endpoint, I have cleanly visualized it on the dashboard, showing the key metrics such as the load, running jobs, and waiting jobs. This will clearly give the researcher or the user clear view of what systems are available, uh, so that they could plan their job runs very efficiently. Then coming to the recent jobs feature, now the user doesn't have to all the time visit the history page. Right from the dashboard, they can manage the recent jobs they have run, on what application they have run, and what's the time submitted and what is the status. To achieve this, I have first used a job listing wrapper, which will give a call to the Tapis Jobs API, and it will get the details of all the jobs the user has run. But using a filter option based on the time they have submitted, we are only showing the 4 most recent jobs on the dashboard. Again, when the user clicks on the view details to get more metadata about the job, we are using jobs detail model wrapper. This will fetch all the job metadata using the UUID of the job. This will showcase more metadata such as what queue they have used, what is the maximum time limit, what are the input labels and everything. This is such a great feature because the researcher can now or the user can now know all the recent job status right from the dashboard without having to navigate to a particular website. And coming to the quick links and tutorial video session, quick links will help the user navigate to to manage their account or to tools and applications and training session. And I have even implemented a user guides and tutorial session for the new users to understand how they can better manage their allocations or create a ticket, which will be right there in the dashboard. Next slide, please. And coming to the machine learning feature that we have worked on, is job failure prediction. This feature is particular for the researchers to predict before they submit a job whether it will be a failure or not. Because every time a job fails, it is a waste of the HPC resources or the user time. So it's a great impact if we could show them whether maybe a risk score or a warning showing that this job may fail because of the memory limits or missing modules. So first, to achieve this, I have thanks to Steve, he has provided me a data set of the history of the job runs, which has different fields such as app ID, job name, status indicating whether the job was finished or queued or cancelled or failed. And then the submit time, end time, nodes, how many nodes they have used, how many codes they have used, and what queue they have used, and all. Using this data, I have done a prototype training the model on CAT Boost and XGBoost. During this initial state, CAT Boost model has outperformed the XGBoost, and we have for the prototype for this data set, we could only get around 2,000 records. Since the TAPIS has been switched to the new version, we couldn't get hold on a lot of records. So the accuracy is around 81% right now. But if we could get more data or more richer data with more fields, I'm sure we can get more accuracy. And the UI integration for this idea is to show a risk score or a warning telling this job might fail, or even suggest why this job fails. Next slide, please. And I just wanted to give you an overview of what's the old dashboard which is currently in use and what's the new dashboard we have developed. This dashboard clearly has a lot of features which will let the user manage the jobs or allocations or even get the system insights right from the dashboard, which is more personalized and more interactive. Next slide, please. And coming to the challenges, the first challenge as soon as we came here was to better understand the architecture or the code base, because majority of it was in Angular. So understanding it and or integrating it with React was a bit of a challenge for us. But thanks to our mentor Jake, he conducted a paid programming session and even walkthroughs of explaining us the complex code base. So thanks a lot for supporting us, Jake. And the next challenge that we felt was the ML integration. Since there are a lot of applications or a lot of ways of using ML, narrowing it down to what could be the best use of machine learning in this part, and how can we better approach it, where to get the data set from, or just how to implement it on the front end. We were having a lot of doubts, and again, thanks to our mentors, Tracy, Jake, Sal, Garrett, Frank, Steve. You guys have really helped us in pointing us in the right direction. So thanks a lot. Coming to the lessons learned, I could definitely say this internship made us understand not only back end and front end, but how collaboration works as well. So right from designing database or integrating APIs to making front end components and displaying the data in much more cleaner way. This internship has been a great experience to us, a great learning platform to us. So thank you for giving us this opportunity. And magic moments, magic moments, one of the best moment for all of us is like a tour of the data center, seeing all the high performance machines up close, in the servers. It's been really amazing. This is not something that everyone could get to experience, so we are really lucky and thankful that we got this opportunity. And even coming to the learning from all the mentors, thanks for always being supportive, making this a good learning experience for us. And even our fellow interns, it was fun working with them and collaborating with all of you guys. So thank you. And we have even explored Austin, so it's been really nice exploring and going to places in Austin. So thank you. This is all from our side. Thank you, guys.
So we're actually going to do questions at the end. So if you can save any questions you might have, just so that we can make sure we have enough time for all the presentations. So you guys are great job, by the way.
Thank you, Mehta.
Are we ready for our next presenter?
Hi.
Okay.
Should I start?
Yes, please go ahead.
Okay. So, hello everyone. I'm Osama Zafar. The teammates I had was Hansol Lee and Cliffel. We were working on the project called ML Hub. It's a machine learning management project. I'll let others introduce themselves.
Hey y'all, I'm Nick. I'm a student at Ohio State, and yeah, it's me.
Yeah, I'm also the master student. I'm the master student at Ohio State University. Yep.
Next slide. So, as I mentioned, the main focus of our project was the ML Hub. It's a machine learning management and platform, and the component we were working on is called artifact ingestion. The main challenge for us as part of the internship was to be able to learn Rust, understand the code base, get familiar with it. Design and develop the plan for the artifact ingestion from the very format it's going to be uploaded in, how it will be packaged, and then how it will be uploaded, the requirements for it, and how it will be processed and stored for the later use, either as a inference loading or for publishing onto other platforms. So that was our whole experience throughout the semester. Hansol?
Yeah, you can go to the next slide.
I'm at the milestones one. You want me to go to the next one after this?
Oh, can you hear me?
I can hear you.
Oh, you can go to the next slide.
Okay.
Sorry.
This one?
This was the next slide.
Hang on. Oh, sorry. Go back to the previous one. My bad. Sorry.
Okay, go ahead.
Yeah, so our major milestones for the project were developing core artifact APIs, and that really includes APIs for uploading and downloading artifacts, where an artifact represents, it can really be anything, but it really represents models and data sets within this context. And then our second big milestone was enhancing the ingestion pipeline. And to do this, we really focused on decompressing artifacts, which are uploaded in the form of zip files. And then our third big milestone was a robust testing foundation. So this included developing like a testing file name convention and conventions for both low-level and endpoint level test cases, and then implementing low-level and endpoint level test cases. And then we also focused on strengthening REST API calls, and we accomplished this by validating the formatting of past authorization headers before passing them on to other APIs used later downstream. Next slide. So these are two sequence diagrams that we developed within the design stage that Osama talked about. And so the sequence diagram on the left is for uploading artifacts, and you can tell because it has with zip file, so you're uploading a zip file. And then the sequence diagram on the right represents downloading artifacts. And both of these diagrams really show the different levels of the software architecture that was designed by Nathan. And so here the presentation layer represents the user-facing API interface. The application layer represents the application logic, and the infrastructure layer represents the backend infrastructure, which could be like databases of different sorts, file storage, and things of that nature. And this architecture really really encourages high cohesion and low coupling, and it was really cool to learn about and get to work with, and then take back to the projects that we were working on before we came here.
So Nick covers the what we are able to accomplish, but a huge part of that process involved overcoming some significant challenges. First and foremost, the biggest challenge was mastering the language, which is not familiar with us. So coming into this internship, we all had programming experience, but Rust was relatively new for us. So navigating its steep learning curve was a demanding but rewarding process. In particular, getting comfortable with Rust unique memory management system, like concepts of ownership and the like borrowing checkers. The another challenge was integrating asynchronous and synchronous code. This became especially apparent when we were developing test cases for the API endpoints or other functions. Service might run perfectly in the running server environment, but then they are behaving unexpectedly within a test environment. Resolving this conflict requires us to go beyond just switching async and await, and like really need to dig into the Rust runtime. It was also a really good lesson for importance of creating consistent test environment. Finally, a more conceptual challenge was sticking it with the project's established layered architecture that Nathan provided to us. It's one thing to learn about software architecture in a classroom, but it was another challenge to apply it in a large real world code base. It requires us to be very disciplined to really understand the responsibility of each layer and resist the temptation to take shortcuts. From this process, the importance of writing code that is not only functional but also maintainable, consistent, and easy easy for future developers. For the future developers is like injected to us. Next slide, please. So working through those challenges was a really good learning experience, and it leads us directly to some of the key lessons that will taking from this internship. First, we gain a much deeper understanding of advanced concurrency patterns. It's one thing to read about synchronous versus asynchronous programming, but it's another to implement them in a real world application. While developing the API endpoints in Rust, we got hands-on experience deciding which pattern we have to use with the circumstances and when. So next thing was the next lesson was in memory safe programming with Rust. Before this, concept like ownership and borrowing were abstract for us, but after seeing the compiler catches the potential memory bugs, it has really clicked to us. We learned how to think about building a reliable software from the ground up with safety built into the very structure of the code. And finally, we learned a great deal about the complexity of the file handling. Our task to implement a recursive decompression for artifact forces us to go beyond just using a library. I have to truly understand the entire process, how the file stream works, and how to handle data buffers efficiently, and how to write the robust code without failing, even with the multiple layer of compression. It was a really fantastic deep dive into what it takes to handle data correctly and reliably in a production pipeline. Next slide, please. Also, we are glad to share a few moments, what we as the magic moments that went beyond the day-to-day work and really defined our internship. The first one we really want to emphasize was the technical breakthrough. We are designing the file upload and endpoint and struggling with how to maintain our clear layered architect while handling large file chunk by chunk. So instead of presenting presentation layer repeatedly calling the application layer, we designed a function that returns the stateful upload session handler. It was the kind of a really elegant solution that solved the problem perfectly, keep the code clean and preserve the architecture. It was the incredible feeling when we accomplished this kind of breakthrough. Next thing was for the first week, we will admit the borrowing checker felt less feature and more like a roadblock while we were learning Rust. But there was a specific moment point that where its error message stopped being frustrating and start to being incredibly helpful. For us, we realized it wasn't just correcting by our synthesis; it was preventing future bugs and guiding us to write safer and better code. And finally, most important moment we had every single day, beyond any line of code and technical achievement, the absolute highlight of our summer was the time we spent each other as a co-worker. We shared the entire experience that we had made this internship truly special. Next slide, please.
Yeah, another great thing that we really got to experience here was the ability to work on ML Hub as well as other projects that we had already come in with and had commitments to. So for me plus Swathi and Gautam, who you'll hear from later, we also had to work on this unified component API known as UCA, which is um, an Icicle project that we were already working on before we came here. And Nathan and Joe were really helpful and friendly with us continuing to develop things on this project at the same time. So that was very much appreciated by them. But so while here, we also developed an integration between the UCA project and something known as Model Commons. And so that really represents the process of writing Patra model cards to the Patra knowledge graph and writing whole models and data sets to Hugging Face, as well as creating model cards for both those models and data sets. So the Patra model cards part was really the process of creating model cards from files and from dictionaries and then writing them to the Patra knowledge graph, as well as validating that the necessary fields were filled in. And then the Hugging Face model commons part was authenticating with Hugging Face, creating Hugging Face repos, deleting Hugging Face repos, writing files to Hugging Face repos, writing folders to Hugging Face repos, and then the last thing that we did with this, which was probably the hardest part, was creating Hugging Face model cards and Patra model cards at the same time with as little information as possible. Next question, or next, sorry, second question. Oof. So another thing we also did while here, which was a combination effort between Swathi, Nathan, and myself, was this model discovery, which we have begun working on but haven't quite finished yet. So the problem that we're really trying to address here is how do you create a model representation that can be used for model discovery tasks? And you really want that model representation to be robust enough to work for a variety of models and a variety of different tasks. So we each brought our own backgrounds to this and our own like knowledge and kind of put it together to come up with a model representation. So the steps to really do that was that Nathan came in with a really well done initial model representation, and Swathi and I helped him brainstorm and refine it a little bit. Then we went on to apply that model representation to different model types and search requirements. And we're really trying to figure out whether or not we could find what we were looking for based on what we already had. And then we came back after that and updated the model representation to address those shortcomings. So the diagram on the right here shows how this will work. And so ML Hub will have a model representation, and then that model representation is the one that we have been designing and developed. And then it will convert, if you want to search the Patra model card knowledge graph, you would convert that to a Patra representation and search the Patra knowledge graph. And then if you want to search the Hugging Face as a site, you would convert the ML Hub model representation into a Hugging Face representation and search Hugging Face. Another aspect of this is if you have another model store or another knowledge graph, you could take the ML Hub model representation, convert it to whatever format that store is looking for, and also search that. So this will be also a continued effort from the three of us.
So, as Nick mentioned, we also brought on some projects. Other than ML Hub, we were working on some other projects. This is another project called Food Security Sandbox. We were working in collaboration with Icicle. I was previously working on it, and with Joe and Nathan's help, I'm continuing in here. The idea of the Food Security Sandbox is to provide a platform for collaborative research to train, model, explore data sets in a privacy preserving manner. The idea is to be able to identify collaborators based on dataset properties and let researchers to explore each other's dataset without actually sharing the raw data, and train machine learning model using federated learning in a completely privacy preserving manner for collaborative learning and research development. Can you go to the next slide? So the system we have been developing for a while is able to provide basic features like identify similar farmers by using machine privacy preserving techniques to identify data matching in a privacy preserving manner, and then allow users, in this case farmers, to talk to each other after identifying them for knowledge sharing, and for researchers to collaboratively train machine learning models using federated learning techniques. On these identified collaborators, we have been working with the idea that in federated learning, if all the collaborators equally participate, it has a higher overhead, using this kind of technique to identify very similar farmers with similar data features and data sets. We can cut down the training time while not sacrificing any model utility. We also have developed a playground and a repository section where publicly trained machine learning models on the platform are allowed to be shared and used by others by submitting your data set, hot loading the model, and running inference on the model. This also brings a little privacy concerns, as models, even in a black box setting where the user only gets the results back from the model, has certain privacy risk. One being membership inference, where anyone can send in a large amount of queries to determine in whether some parts of that data was used to train the model or not. So we also develop techniques for membership inference risk analysis. We train and attack our own models is to determine whether they are going to leak data in real world production setting or not, and if there is a amount of risk, then the model owner is notified, and there are certain defense mechanism that can be deployed, for example limiting the number of queries per user, or adding noise to the results that are sent back to the user. So these techniques are used to protect the model in a black box deployed settings. So the food security sandbox is designed to promote collaborative research, especially in a domain that where people are hindering and hesitant to share data sets publicly. Thank you. And I would like to thank Nathan for helping and guiding this project as well, and Dr. Yu as well.
Thank you. Great presentations. We're going to go to our next presentation. Swathi, do you want to share your screen?
Hello everyone, am I audible?
Yes, we can hear you.
Yeah, thank you all for joining today's session. So we will be talking about our work in SGX3 internship, me and Swathi. So before that, about me. So my name is Gautam Gururaj Molakalmuru. To make everyone's life easier, you can call me Gautam, like a Gautam City from Batman. As you can see from the mascot, I am studying at the Ohio State University, completing my master's in computer science. I'm passionate about software engineering, but over here I am more working towards software engineering with AI ML, even in my icicle projects as well over here. Over to you, Swathi.
Hello, everybody. Hello again, I would say. My name is Swathi. I'm a PhD candidate now at the Ohio State
Swathi,
University.
you're coming across a little bit broken.
Is it better now?
No, not yet.
Okay, let me try. How about now?
Much better. Thank you.
Is it better now?
Yes, you're better.
Oops. I can't hear anybody.
We can hear you.
Okay. Okay. It's probably the sound of my laptop is going. Okay. Hello, everybody. Hello again. My name is Swathi, and I'm a PhD candidate at the Ohio State University. And before starting my PhD, I did my master's from University of Minnesota, and this is my third time as an SGX3 intern. A quick brief about my area of research is building and curating AI-driven workflows for cyber infrastructure optimizations. And currently, I'm interested in looking on how I can apply my research for edge-centric workflows, especially focusing on the animal ecology pipeline. So today we have a special guest joining us, which is this mini toy, and we'll know why in a couple of slides. But we will go through our problem statement, what domain we have been applying our project to, and why AI ML helps animal ecologists in general, and what are the challenges applying AI ML to animal ecology is brought up by the modern cyber infrastructure, and obviously the field planner, which is the solution that we have proposed for the modern challenges, and how we are going to convert the ML field planner and take it to the wilds using a smart backpack, while also addressing the challenges and milestones that we came across the projects, and finally wrapping up with the aha moments of the project. So very little brief about the domain, which is the field of animal ecology. In the paper Perspectives in Machine Learning, it's already well established that there are a ton of AI models out there and researchers out there that can actually use AI models sometimes as is and solve the problems in the wilds. For example, in this use case, we can see that you can simply apply a very simple object detection model to remove all the blanks that are there in the field by reducing the amount of images to study to 15%. So that is a simple vision model that you can apply to the field of animal ecology. So with this evolution, we also see that simultaneously the cyber infrastructure space is also scaling up. And now the compute is no longer restricted to center, but rather the compute and data movement are distributed across the new ecosystem, which is edge devices like our phones or laptops, or even supercomputing centers like the one at TACC. But the question is, to what extent is the field of animal ecology able to extend or utilize this ecosystem? So in this particular example, we can see that there's a lot of compute that could be packed onto the edge devices like your camera traps or drones to actually do the field study. So in this case, you're able to see that unique zebra identification is happening by the stripes that can happen on the edge. Or you can do the landscape study, or you can even do intrusion detection or poster detection. And the scope is vastly beyond the examples that we see here. But the question is, we have data and we have a bunch of models out there. So is it as simple as taking the data or taking a model, deploying it on a drone and flying it to the target area and getting results? Is it as simple as it's being projected in this slide? And the answer to that is definitely not, because sometimes people can say, hey, mega detector is there because that's very popular in the field of animal ecology. Can we just take on their claims that says, oh, if mega detector 6 is like 6 times or 5 times faster, and it's very tinier than the previous models, then it's obvious that every ecologist should use this model and apply to their domain. But when we did that, we saw that the results were not super accurate. Like here, if you see, despite the fact that mega detector 6 claims to be better and accurate than mega detector V5, we saw mega detector V5 is doing way better than V6 and even the fine-tuning versions of the model. And the catch here is these claims are valid only on benchmark datasets, but most ecologists want to focus on their own datasets and their own devices. That's where the ML field planner comes in, but here you'll see what is the bigger challenge. The bigger challenge is we have a ton of datasets out there for animal ecologists, which have different or diverse ranges of data. For instance, here we are just looking at images, but you could see that some images are drone images and some are from camera traps. So they have different angles, different directions, and different resolutions. So it's not like one model fits all approach. And at the same time, devices are also different. Sometimes you might want to run the model on the edge or at the near edge. So even these decisions will be impacted by whether they have direct power or are they operated on battery and other constraints. And obviously models, right? We know every day there are a ton of papers released on AI. And currently with what we tested on 3 different YOLO version models, and each one of them has its own variation. That is for edge, that's for memory constraint, energy constraint. And as we speak today, there's speculation that YOLO 14 is going to roll out soon, probably this week. So with this large scale of confusion, like what model to use when data set is changing and what devices to deploy it on, we need a plan. We need a tool that can help ecologists plan on to select a model, select a device, and given their data sets. That's where the ML field planner, which is talk of the town at this point, is providing a solution to, which is like, how do we integrate an independent set of components into a workflow so researchers can experiment which models to use on which data sets, and figure out what would be the power implications, memory implications, and the latency, of course, on those models. So this is the core architecture of the ML field planners. ML edge server, which literally sits on the edge device. And it has a core event loop here that enables researchers to do this plug and play sort of a thing. For instance, input. If we are providing input for our field planner, the input could be coming from an image generation plugin or an image detection plugin. So if we want to run the experiment in a simulation mode, we can simply run or package this core event engine with image generation plugin. But if we want to deploy it on the field, we can swap it out to image detection plugin. So similarly, we can choose to have an image scoring plugin, or we can choose not to store images and maybe send a trigger using a communication plugin. So here, all these components are plug and play and how researchers want to stack their software with one another. And this is a very core important piece of the ML field planner. Excuse me. So another important insight while working on this project during the summer we have seen is accuracy was the only metric that we were displaying earlier. So this time we just took this tool, the ML field planner that we worked on for the last couple of years or months, to the colleges, like the computational colleges like Jenna, and asked what could be added to this to make it more efficient for you. And she pointed out that maybe we add more metrics. So it will help researchers figure out which model to use based on which metric. For example, if I want to deploy my field planner on a drone, then I might have to look at false positives, because if there are less false positives, then that's the model that I want to deploy in an autonomous drone. But if I want to deploy the same model, same YOLO model, on a camera trap where I'm cleaning up for noisy images, in that case, precision might be important. So the choice of which tool or which metric I'm using will also change which model I'll be selecting. So we are currently working on getting more metrics into the ML field planner. So the same model could be deployed at different scenarios based on what the users want or what the animal ecologists want. So moving on from this, so with the help of ML field planner, now I know, for instance, if I'm using drone, I might use a YOLO V5 large because it has less false positives. And I'm using a camera trap, I might use a YOLO VC because it has less precision. So I now know the architecture of my devices, I know what models to deploy, but the question is what next? At the planning stage, I know model, I know device, but what next? What's next is the ML edge server workflows, wherein we are actually the plan is to package the software with the hardware together and take it to the wilds. So the next couple of slides will be talking about the smart backpack, and the ideation of the smart backpack started with the question, what's in my backpack, that Dr. Joe and Dr. Chris started talking about in the iSchool All Hands meeting a couple of months ago. And Gautam would take it forward from here. I'm still trying to find my cursor on this big screen.
Yeah. So until then, yeah. Thank you. Just one.
You're good now.
Yeah. Thank you, Swathi, for such detailed explanation. Yeah. So what's in my backpack? So we would have the camera traps, the near edge laptop, the drone, and the router for LAN connection. An ecologist would go into the wilds, connect these components, test the connections, install the software. Like Swathi mentioned, we would have the relevant ML model in place, and then the ecologist would run the software stack on the camera trap. And the ecologist would keep those camera traps on the highly activity area where we can detect more animals, as in in an elevated place, like on top of the hill or top of the trees, etc. So as you can see in this image, the camera trap detects the motion, triggers the event, and then the ML model will score the image, and then it detects whether if the animal, it would say if the animal is detected with X% confidence, let's say like a 50% confidence. If it is above a certain threshold, then it would publish an event for downstream components to do the subsequent actions. In our case, autonomous drone would fly near the camera trap and would detect more, it would capture more data, which would be further processed to the center. And as for the project goals, we had to set up and run the backpack camera trap pipeline on the TACC premises, and then test the end-to-end flow from motion detection to image scoring to downstream publishing. So there are certain we had to observe, we had to look out for certain bottlenecks and opportunities for improvement, especially in terms of the latency. As of now, since we were doing in the simulation mode, we had an acceptable latency of around 20 to 30 seconds. But then now that we are thinking about a real life use case, we had to bring down the latency for much shorter time. So that's why we had to propose few enhancements that could improve the efficiency without compromising on the detection quality, considering the constraints of a edge devices. And as for the milestones, we selected, like Swathi mentioned, there are plethora of model options that we can choose from, but we did our testing and we selected few ML model that worked best for the demo, which had high accuracy, but as well, also importantly, had less inference time. And it also should be lightweight models. We completed the setup, and then we identified few operational considerations that could help the pipeline run more efficiently. Yeah, as you can see in the image as well, the entire end-to-end flow from the image detection to the publishing of the event, it takes around 2 seconds. And I'll just give the benefit of doubt that the animal, only the plush toy is being detected, and I'm not part of that animal consideration. So even the accuracy is good enough in our case. And as for the challenges, there were few challenges, especially with the new framework and the new tech stack like Rust, and then also balancing between speed and accuracy. Even though it has high accuracy, we also need to make sure that it is lightweight as well. And also one other thing that we thought as a challenge is needing a basic understanding across many areas like networks, hardwares, ML models, along with the software engineering. Yeah. And as for the lessons learned, it was a very enriching experience to work on a edge device to center continuum. There were working in this pipeline gave us a lot of understanding, especially the complete context is very critical since many decisions are usually situational. So having a complete picture helps to make a better choice. And also, I think special point that I wanted to make as a software engineer was the logging system is critical, especially in a pipeline system. It helps in tracing, debugging, and just understanding of the entire pipeline. And as for the magic moments, like my other fellow mates have mentioned, I can go on about all the magic moments. It might take another half an hour. I don't want to bore all of you guys, but if I have to, break it down into 3 main parts, it would be like working on an exciting project like Camera Trap, collaborating with incredible set of mentors and fellow interns. And lastly, but equally important, working in a facility like TACC. It was inspiring and yeah, loved it. Over to you, Swathi.
Okay, so this summer, unlike last summers, I was able to attend PERC to represent both Icicle and SGX3, but this time I had more opportunities to attend beyond just PERC. So I was at International Summer School, International HPC Center, giving poster talks about the entire Icicle pipeline and the involvement of chapters with different phases of my work that evolved during the last 3 fellowships. And apart from that, obviously, PERC, winning another best paper at PERC was again definitely the best aha moment, especially considering that the first PERC best paper I got was when I was the first year intern at SGX3. And I would really thank Gautam this time. He was really, I would like to give a special shout out to him. When I was away for conferences, he was able to take tasks for me and we were able to coordinate really well. So the work would not be hindered. So that's like a special shout out to Gautam. And thank you, Dr. Joe. Thank you, Nathan. Thank you, Christian, for helping me out understanding different components over the all 3 summers and beyond summers, just summers.
Yeah,
Thanks.
thank you all.
I'm going to swap back real quick. So thank you everyone for a wonderful job. I just wanted to really say thank you to our sponsors, obviously NSF, SGX3, but also Icicle for sponsoring some of our internship program, and TACC for hosting and providing the space and all the resources so that the interns could enjoy this experience together. Our next internship program really rolls around pretty soon after this, starting sort of October, November. So you can find out more information about sciencegateways.org/internship. So if you have any students or prospective folks who are interested in applying for next year, we're really excited to have this internship program year after year and the impact that we make. I really loved all the presentations. You guys did a great job. We'll see if anyone has a few questions for our last 2 minutes. Feel free to unmute, or I can read from chat as well, but feel free to unmute if you like and ask a question. Okay, doesn't appear that we have any questions. Thank you so much. Thank you, interns, for a great job. I can't believe we're already over. Good work, and yeah, thanks everyone for attending.
Thank you all.
Thank you all.
Thank you, everyone.
Thanks, you all.